Bismillahirrahmanirrahim. In this lecture, we are going to study synchronous motor introduction, its equivalent circuit and operation. We already studied the synchronous generator induction motor, and this synchronous motor resembles with the synchronous generator, and there is just the one difference that synchronous generator converts mechanical power into electrical power, and this synchronous motor converts electrical power into mechanical power. So other all construction and all things of the synchronous motor is similar with the synchronous generator. It has its own stator winding which is similar with the generator, and it's also have its rotor winding, and rotor winding have to be supplied the DC current, field current. So this synchronous motor have two magnetic field, one magnetic field by the external three-phase supply on the stator winding which is denoted by BS, and other magnetic field is due to the field current present on the rotor which is generated by BR. Basic principles of motor operation. A synchronous motor is the same in all respects as a synchronous generator, except that the direction of power flow is reversed. In synchronous generator, power flows from rotor towards stator, and power is converted from mechanical into electrical, but in the synchronous motor power flows from the stator side towards the rotor, and power is converted from electrical into mechanical. So this is the basic difference between synchronous generator and the synchronous motor. To understand the basic concepts of a synchronous motor, look at the figure shows a two-pole synchronous motor. That's how synchronous motor looks like. I am going to draw it here. If this is its stator, then this is its rotor. Rotor have its own magnetic field which is BR, and stator have its own magnetic field which is generated by BS. So this is the two pole synchronous motor phasor diagram of the magnetic field. Let's study that the field current IF of the motor produces a steady state magnetic field BR. On rotor there is field winding present on the rotor. A DC current is supplied to this winding, and this DC current produces a steady state magnetic field BR, which is this one. Then a three-phase set of voltage is applied to the stator winding of the machine, and on the stator winding produces the current, and which produces its own magnetic field, and its magnetic field is generated by BS. Now when we supply the three-phase voltage and three-phase current to the stator winding, the magnetic field produced in the stator is rotating in motion, as we study during the study of induction motor, that when we supply the three-phase supply, the magnetic field is rotatory in motion. So the same magnetic field start rotating with some speed. So as the stator magnetic field starts is rotating, so the magnetic field of the rotor try to catch up this magnetic field. For example, if stator magnetic field have a pole north is here, so BR if have a pole south is here, so this south try to catch up this north, and that's how it starts rotating in the anti-clockwise direction. Same like when we close the two magnet and one magnet try to catch up the other magnet. So same phenomena occur inside the synchronous motor, that the rotor magnetic field tries to catch up the stator magnetic field, and stator magnetic field is rotating, so rotor also starts rotating. So the next slide is the equivalent circuit of synchronous motor. A synchronous motor is the same in all respects as a synchronous generator, except that the direction of power is reversed, which we already studied in the previous slide, that synchronous motor resemble approximately the same the synchronous generator. So the equivalent circuit of synchronous motor is exactly the same as the equivalent circuit of synchronous generator, except that the reference direction of IA is reversed. So the equivalent circuit of synchronous motor and synchronous generator resembles, just the direction of IA is changed. Because the direction of power flow in the machine is reversed, the direction of current flow in the stator of the motor is reversed. So this is the equivalent circuit of synchronous motor, and the same kind of equivalent circuit we construct during the study of the synchronous generator. So I am going to draw it here. Like this is the field circuit, rotor winding. This is the adjustable resistance to control the field current, field resistance, field inductance, and VF. This is our adjustable, this is RF, and this is LF. So as it is three-phase synchronous motor, so this is phase 1, and this is phase 2, and this is phase 3. This is J of X as synchronous reactance, armature resistance, and internal generated EMF, and the V phase 1. Similarly, synchronous reactance, armature resistance, internal generated EMF of V2, and this is A of 3 and V phase 3. So the difference is this one, which I am going to draw it here. IA. In synchronous generator, the direction of IA is in this way, but in the motor, the direction is the reversed. So the IA direction is now this one. So that's how the equivalent circuit of synchronous motor looks like. From synchronous generator, we studied that EA is equal to B phase plus J of X as IA plus RA IA. But in case of synchronous motor, as the direction of current is reversed, so this formula little bit change. Now this V phase which is supplied to the stator winding is equal to this voltage drop, this voltage drop, and this voltage. So now in the synchronous motor, V phase is equal to, first voltage is applied to the stator winding, voltage drop occur here, then voltage drop occur here, and then this voltage. So V phase is equal to the sum of these three voltages, and first one is IARA plus J of XS IA plus EA. And at the end EA is equal to V phase minus J of XS IA minus RA IA. So now these two equations resembles with each other, just signs are different, and this sign shows that the direction of the current is reversed in these two circuits. So the next heading is the synchronous motor from a magnetic field perspective. The phasor diagram of the generator operating with a large field current is shown in figure A, and its corresponding magnetic field is shown in B. This phasor diagram we studied during the study of the synchronous generator, that this phasor diagram looks like this in case of the lagging load. And this is EA, this is J of XS IA, this one is the V phase, and this is IA. This is the angle delta, and this is the angle theta. So that's how the phasor diagram of synchronous generator we already studied looks like. So how does its corresponding magnetic field look like? As we already studied that this is B net, that B net corresponds to V phase, BR corresponds to EA, and BS corresponds to armature reaction. So it is like that, this is BS. So that's how the magnetic field looks like. So BR produces EA, B net produces V phase, and the stator magnetic field produces the armature reaction. So that we already study in the synchronous generator. Now how the phasor diagram of the motor looks like. In phasor diagram of motor, V phase is kept at the same place. As we see that in the motor the direction of current is reversed. So if direction of current is reversed, so the armature reaction is now given like this, and the resultant EA will be this. But in this it is given like that. V phase will be the resultant in this case. So that's how the synchronous motor phasor diagram looks like. This is IA, this is theta, this is delta. And if we have to draw corresponding magnetic field diagram, so the corresponding magnetic field diagram, V phase corresponds to B net, EA corresponds to BR, and J of X S IA corresponds to BS. So that's how the magnetic field diagram looks like. This one is for the generator, and this one is for motor, for synchronous motor. The quantity J of XS points from V phase to EA in the generator, V phase to EA in the generator, and EA to V phase and EA to V phase in the motor. The reference direction of IA was reversed in the definition of the motor equivalent circuit, so that's why. And in a generator, EA lies ahead of V phase and BR lies ahead of B net. In a motor, EA lies behind the V phase and BR lies behind B net. So that's how the magnetic diagram and magnetic field perspective of the synchronous motor looks like. And this is the difference between the magnetic phasor diagram of synchronous generator and the synchronous motor.